Good evening to all of you. Welcome to Gate Wallah. Audio video is clear to all of you. Kindly confirm in the chat section. Okay. So in the last class, we have discussed about plume behavior. So we have discussed about ELR, ALR, both concepts we have discussed, and then we have discussed about the plume behavior. Total 7 type of plume behavior we have seen. The best one is the lofting and the worst one is fumigation. So I think all of you have already watched that class. Now let's start the today's discussion. The topic of the day is oxygen sag curve. Oxygen sag curve. Okay. Now, just like the previous class, first I will give you some intro about the basics or the introduction for the oxygen sag curve, and then I will come for the topic. Oxygen sag curve, first of all, it's a part of disposal of sewage effluent chapter. So this topic is from disposal of sewage effluent chapter. This oxygen sag curve is something which is related to the how wastewater which you have added into the waters, river stream, or maybe in any other flowing stream, how they react, what they do, all these information you will get it here in this topic. So let's start the discussion without wasting time, and that is oxygen sag curve. Oxygen sag curve. Now what happens during the cell purification process? During the cell purification process, now your question will be, sir, what is this cell purification process? Every water body is having a capacity to self purify its own water, but up to a limit only, not unlimited capacity they are having. Up to a limit they have a capacity to self purify the water. Like river is having a self purification capacity. For a self purification capacity, some mechanisms are there, like one of the mechanism is dispersion and dilution, another is the oxidation and reduction, next one is the topography, or you can call it as a aeration part. Turbulence also related to that. Next is something what you can call it as sunlight part. So all these are basically helping that river water to purify that own water with the best possible way in a completely natural manner. No chemical, completely natural manner. Now, when you talk about the cell purification capacity, this oxygen sag curve is very important for you to understand. Now, let me draw this oxygen sag curve first to you. During the cell purification of river water or cell purification, you will find two type of thing which is happening simultaneously. Two process which is happening simultaneously. One is the first process is the depletion of oxygen. That is something what we are calling it as deoxygenation. So deoxygenation will be, deoxygenation is happening in the while the cell purification process is going on. That time deoxygenation will occur. Why deoxygenation? Because see, organic matter you are degrading na. If organic matter you are degrading, these microorganisms definitely demand oxygen, and they will take oxygen from the water itself, and for that reason you will find the dissolved oxygen concentration level in the waste in the river water is going down as the degradation process, as the decomposition progress. In that case, your dissolved oxygen value will go down. So one process is depletion of oxygen. One process is depletion of oxygen. Another process is reoxygenation. So let me draw both the process for you. In this oxygen sag curve, in the x-axis you have time, and in the y-axis you have dissolved oxygen. Dissolved oxygen. Every river water will have a saturation capacity. That is what we are calling it as saturation dissolved oxygen concentration. So this is something I am denoting it as DO saturation. This point is something telling you about DO saturation. Normally, you will find that river water is not having the DO saturation value. Something lesser than that. Something lesser than that. Even though degradation is not started yet, but still you will find the the river is not having the dissolved oxygen equal to DO saturation. They are having something lesser than that. Let's say here. This difference we are calling it as D naught, initial oxygen deficit. Initial oxygen deficit. Now what happened? You have added the wastewater into the river water. Now at time 0, when you add that wastewater into the river water is not having the DO saturation, something lesser than that you have. As the time progress, the dissolved oxygen value will degrade, or you can say the dissolved oxygen value will decrease. Why it is decreasing like this? It is decreasing exponentially. Why it is decreasing like this? Because the microorganism gonna use this oxygen for the degradation, for the decomposition of the organic matter or the matter which you want to degrade. So in that case, you will find there will be some oxygen demand, and to fulfill that oxygen demand, there will be depletion of oxygen you will find. And this is something what this curve is showing you, or this curve is representing deoxygenation. That's why this curve name I am giving it as deoxygenation curve. Deoxygenation curve. Deoxygenation curve. At the same time, when this deoxygenation thing is happening, at the same time, simultaneously, this cell purification capacity will also work. Cell purification capacity will also work. And because of that, there will be a reoxygenation process also taking place. So reoxygenation process is also taking place. So the curve for the reoxygenation part, it will go like this. It will go like this. This is the reoxygenation part. See, in a normal life, or I will say in a natural condition, both things are happening at a time simultaneously also, and you will only see the cumulative effect of this. But right now, to explain you, I am showing you both the process separately. One is the deoxygenation curve, another is the reoxygenation curve. Reoxygenation curve. Now, as I told you, actually these two processes are occurring simultaneously only. So the final effect which you will get it will be like this. It will be like this. This curve, my dear, we are calling it as, this curve we are giving a name as Oxygen Sag Curve. First of all, this curve is giving you the value of dissolved oxygen. That's why the name comes oxygen. Here you are getting a sag, so that's why Oxygen Sag Curve. Now in this Oxygen Sag Curve, if you notice this reoxygenation curve and the deoxygenation curve separately, deoxygenation curve is decrease, like showing you a exponential decrease. Reoxygenation curve is showing you increase with the time. At a point when this crosses, you will see slowly as the time crosses, as the time progress, the deoxygenation curve is now dominated by the reoxygenation curve. And that's something which you can see in the Oxygen Sag Curve also. This Oxygen Sag Curve is basically the resultant or the net curve of these two. So here you will notice at this point you are getting the maximum deficit. This is something what we are calling it as critical deficit or maximum deficit. At this point, the dissolved oxygen, if you want to find it out, the dissolved oxygen at this point, this dissolved oxygen value will be, how you can find it out? Simple. Dissolved oxygen at any point, if you want to find it out, it will be DO saturation minus D critical. So this I am writing particularly as DOC, dissolved oxygen at critical time. Where DC is the critical oxygen deficit or maximum oxygen deficit. Other than that, other than this point, any other point if you are taking it, any other point, let's for example, you have taken this point. So this is the time. This will be the dissolved oxygen at time T. This will be the DT, which is oxygen deficit at time T. Is that clear to all of you? Is that clear to all of you? First of all, tell me quickly whether this oxygen sag curve is clear to all of you or not. Clear to all of you now? Now, all these values, this DT value, oxygen deficit at time T, critical oxygen deficit, all these values is given by a model, which is something what we are calling it as Streeter-Phelps equation. So Streeter-Phelps actually studied this complete oxygen sag curve, and based on this, he has given a model, and that model gives you all these formula. Like the first formula is, which already I told you, dissolved oxygen at particular time T. If you wanted to find out, it will be dissolved oxygen, that is saturated dissolved oxygen, minus DT. So here I am writing all the term for you so that you guys will not forget. The first term which I have used, that is DO sat, that is saturated dissolved oxygen concentration. All the terms need to be very clear. Second term which I have used here, that was D naught. D naught is initial oxygen deficit. Initial oxygen deficit. Okay. The next term which I have used, that is DC. This is something which we are calling it as critical oxygen deficit. This is also called as maximum oxygen deficit. Instead of critical, you can also call this as maximum oxygen deficit. Then DOT. DOT is the dissolved oxygen concentration at time T or after time T. Other than that, some other terms are also there. Next one is the K1, or we can also call this as KD. It is basically rate of deoxygenation. Rate of deoxygenation. So this curve will have some rate. That rate we are calling it as deoxygenation constant or rate of deoxygenation. Similarly, reoxygenation rate of constant will be also there. That is something which we are writing it as K2, that is equal to KR. We also represent K2 as KR, that is rate of deoxygenation. deoxygenation. All the terms are clear? All the terms are clear? Now you can see this Streeter-Phelps equation. Now you guys can see this Streeter-Phelps equation. The first equation gives you DOT. There's something already I told you. Dissolved oxygen at particular time, if you want to find out, it will be DO saturation minus DT. Like this similar formula we have, if you want to find out dissolved oxygen at a critical time, that is the minimum dissolved oxygen value. If you want to find it out, it will be dissolved oxygen that is saturated minus DC, critical oxygen deficit. That is for this time. Here you are getting the minimum dissolved oxygen value, maximum oxygen deficit value. Now, other than that, any general oxygen deficit, if you want to find it out. So one more thing I have to write it here, that will be DT. So DT is the, or it's better right here, DT is the oxygen deficit after time T. After time T. So that will be equal to K1 into L0 divided by K2 minus K1 e to the power minus K1 into T minus e to the power minus K2 into T bracket closed plus D0 e to the power minus K2 into T. In this, L0 is the ultimate BOD. In this, L0 is the ultimate BOD. In this, L0 is the ultimate BOD. Is that clear to all of you? Is that clear to all of you? Okay. Now, for DC, for critical oxygen deficit, the formula is simply like K1 upon K2 L0 e to the power minus K1 into Tc. If you want to find out the critical time also, it is 1 upon K2 minus K1 ln K2 upon K1 bracket 1 minus D0 K2 minus K1 upon K1 into L0. So this will be the formula for the Streeter-Phelps equation. Streeter-Phelps equation. Clear? You have to remember this formula if you want to solve question based on this. You all have to remember this formula. If you want to solve question based on this, you all have to remember this formula. You have to remember this formula. Okay. Now, Now in this oxygen Sag curve, as this is curve which is formed, sir, all the formulas are important. Yes, all the formulas are important. Now, in this oxygen Sag curve, if you talk about, this is basically a part of your cell purification process. During the cell purification process, this oxygen Sag curve will be formed. Now what we have done it, this oxygen Sag curve, this curve I have actually divided into 4 parts. Actually, I have divided the zone of pollution, like when you will mix the wastewater at the initial point, after that, what will be the different zone of pollution? That is something which I have divided, but that division part I can show it to you in this oxygen Sag curve also. So first I will give you the small theoretical part and then I will show that part into the oxygen Sag curve for you. Total, first, when you add the wastewater into the river water, the first zone which will start from the discharge point towards the downward direction of the river, towards the flow direction of the river, that is the first zone which we are calling it as zone of degradation. Zone of degradation. What is that? It is found up to a certain distance downstream of the point at which the sewage is discharged into the river. In this zone, generally you will find in this algae dies but fish survive. Algae will completely die. Fish can resist up to a limit. Water becomes dark and turbid because in this phase degradation is started. DO reduces up to 40% saturation. 40% saturation. So I'm showing you that part in the this oxygen Sag curve. So this part you can call it as the first part. This is the first part, zone of degradation. After zone of degradation, the second phase will be zone of active decomposition. Active decomposition. Now degradation is at different level. It is a zone of heavy pollution zone or heavy pollution zone. Here the water becomes darker than the zone of degradation because now you are in a prime degradation phase, not early degradation phase. Now you are in between or the maximum rate of degradation is taking place. DO may even fall to 0. Here you will get the maximum oxygen deficit. Here you will get the maximum oxygen deficit. Fish will completely disappear here. But the good thing is that at the end of this zone, again the DO concentration will reach up to 40% of the saturation DO, because what happens, if you see this oxygen Sag curve, in the first part where you are getting the oxygen, where you are getting the maximum oxygen deficit, in this zone, you can easily say that which curve is dominating or which rate is dominating. Rate of deoxygenation is dominating compared to the rate of reoxygenation. But as you passes this point, as you go in the downstream direction, much further direction, you will notice now the reoxygenation rate is getting dominated, or reoxygenation curve is more than the deoxygenation curve. And because of that, you can see the oxygen value is also, it is rising. So it will go towards the saturation value. Now, the second phase which we are talking about, that is zone of degradation. It lies here. Here you are getting the maximum oxygen deficit also. So that's the reason I told here DO may go up to 0 also, because it is a very prime degradation phase. Maximum degradation is happening in this only. Completely bad smell you will get it. The water becomes completely black for you. This is the heavily polluted water which you can find. Okay. Now, but good thing, as I told about this zone, is that at the end of the zone, again you will have around 40% of the saturation value. That is something which you will achieve, because in the same zone you are getting some amount of this part of the oxygen Sag curve, where the reoxygenation is dominating compared to the deoxygenation. Okay, now the third zone. Third zone is what we are calling it as zone of recovery. Now in a zone of recovery, what happens? Your BOD value will fall down, the BOD value will decrease. Organic matter will produce nitrate, sulfate, phosphate and carbonates. DO content rises above 40% of the saturation, that means your value of oxygen content is now rising it because the degradation is over. Now the third zone, fourth zone will come, that is zone of clear water. In this zone, you will find the DO will rise to its saturation value, but pathogens will remain, may remain. So here, this is the phase. After the 40% saturation, then this is the phase of zone of recovery, and then this is the phase of zone of clear water zone. This is the third zone, this is the fourth zone. This is the second. First, second, third, fourth. So if you add a wastewater into the river water, if you add wastewater into the river water, automatically this four zone will be formed in the downstream direction. First, zone of degradation, second, zone of active decomposition, third will be zone of recovery, and the fourth will be zone of clear water. So good thing is that good thing about the river water is what? They have a self purification capacity. Once you add some amount of wastewater at the starting, by the time it reaches zone of clear water zone, your water is crystal clear, your water is completely ready to use it again. So that is the beauty of river. Now the issue which you are talking about, river pollution and all, that comes because, for example, if river is dealing with a particular wastewater which you have added at a particular point, as these zones are formed and the water is getting purified, in between you have added another wastewater. So you have actually added more wastewater compared to with respect to the self purification capacity of the river. So if you add more, in that case the self purification capacity of the river will not be sufficient to handle that much amount of wastewater, and because of that you will find the river water is polluted. Otherwise, if you leave that river for a few months, you will find the river water is having a capacity to treat itself. They are having a capacity, that is what we are calling it as self purification capacity. I hope this point is clear to all of you, and these zones are also clear to all of you. Sahu is asking, sir, are the live classes as per the new syllabus for GATE? Yes, my dear, we have already updated the thing, and those who are preparing for 2027 batch, those who are preparing for 2027 GATE exam, either GATE or ESE also, the syllabus is updated and accordingly we are teaching. So no need to worry about that. Clear? Okay. Now, if this part all of you have understood, and this particular slide where all the formulas are there, if you remember this formula, then we can try a question because I want you guys to be very comfortable with the formulas. For that reason, I am giving a question to all of you. Just first read this question properly. Read this question properly and note down all the given data. That's the only thing you have to do. Read the question properly and note down all the given data. Okay, so I hope you guys have noted down all the given data. The minimum flow of a river is 50. So the QR for river that is given to you as 50 meter cube per second. All of you solve this question with me so that you will not have any doubt in the formula. Having a DO content, that means the river is having a DO content of 7 milligram per liter. In bracket, they have mentioned the 7 milligram per liter is actually 80% of the saturation. So by that I can find it out. DO saturation, it will be 7 divided by 0.8. How much it will be? You guys can tell me. Next data, BOD5. So BOD5 for the river is something which is given to you as 8 milligram per liter. Okay. It receive a wastewater discharge. So now they are giving data for the wastewater, which is QW 5 meter cube per second. With a BOD5, that is 200 milligram per liter. And no DO. Dissolved oxygen content for the wastewater is completely zero. The rate constant of deoxygenation, that means K1, it is 0.5 day inverse, and K2 will be 1 day inverse. Clear? Velocity of river flow is also given to you. Velocity of river flow is also given to you as 0.8 meter per second. 0.8 meter per second. Calculate the distance in kilometer downstream from the point of wastewater discharge where minimum DO occur. Where minimum DO occur. So they want distance in kilometer in the downstream from the point of wastewater discharge where the minimum DO occur. That means they are actually asking you to give an idea about the critical oxygen deficit, where you are getting the minimum DO. There only you are getting. So basically you need to find out TC, critical time. If you are able to find out critical time, they have already given you the velocity. Velocity into time will give you the distance. So ultimately they want distance, but to find out distance, you need to find out critical time, which is TC. Okay. But to find out TC, do we have formula for this? What is the formula for TC? Do you remember that formula? TC is equal to 1 upon K2 minus K1 ln K2 upon K1 1 minus D naught K2 minus K1 upon K1 into L naught. This is the formula that we know. Now, according to this formula, we have K2, K1 that is given to you. L0 and D0 is something which is not given, that we have to calculate it. Okay. So let's start with D0 first. But to find out initial oxygen deficit, I need two things. First thing, I need saturated dissolved oxygen. So this will be 7 divided by 0.8, so 8.75. Okay. Now, I need two things. One, I need BOD5 mix. It will be equal to BOD for wastewater into QW plus BOD for river water into QR divided by QW plus QR divided by QW plus QR. QW plus QR, if you do it, it will be 5 plus 50. 5 plus 50. What about QR? QR is 50 into BODR. BODR is 8, which is given to you. BOD 5W is 200. Into QW, which is 5. So BOD 5 mix, how much you guys are getting it? According to my calculation, I am getting around 25.45. 25.4545. All of you guys are getting the same. So if you got the BOD5 mix, I can find out the L0, which is ultimate BOD. It will be BOD5 mix whatever you got, 1 minus e to the power k1 into 5. So 25.4545 divided by 1 minus e to the power k1. Value of k1, how much you have? 0.5 into 5. So L0, how much you guys are getting it? $27.73. $27.73. So one thing which we got, that is the L0. Now we have to go for DO mix. Again, the similar type of formula. DO of river into QR plus DO of waste water into QW divided by QR plus QW. So DO mix, how much you guys are getting it? This will be 55, 5 plus 50. DO for the wastewater is given as 0 and the discharge is 5. River water DO is something which is given to you as DO of river is 7. So 7 into 50. How much DO mix you guys are getting it? You guys can also answer in the chat section. Don't simply copy paste from my calculation. You guys can also solve and give me the answer. 6.3636. This is the DO mix. So the initial oxygen deficit, if you want to find it out, it will be DO saturation minus DO at the initial, the mix which we are talking about. So DO saturation we have how much? 8.75 minus 6.3636. How much it will be? I'm getting around 2.3864 milligram per liter. This is the D naught value. So I got the D naught, I got the L naught. These two things are required for me to use this TC formula. Now I am ready to use it. So TC will be equal to 1 upon K2. K2 is 1. So first I will write the formula. K2 upon K1 ln K2 upon K1 1 minus D naught K2 minus K1 divided by K1 into L naught bracket closed. So this will be 1 minus 0.5, so 0.5 ln 1 upon 0.5, so 2. 1 minus D naught is 2.38. K2 upon K1, this will be 0.5 divided by 0.5 into L naught is, L naught we have calculated now, 27.73. How much time you got? The time value you will get in days, because 1 upon K2 minus K1 you have done it now. So K2 minus K1, the unit of K is day inverse. So the time will be in day. Give me the value. Now this time I am expecting all of you to give me the value in the chat section. This time I am expecting all of you to give me the value in the chat section. How much you guys got? Nobody has solved? According to my calculation, I'm getting around 1.2063. Distance is equal to velocity into time. Velocity is 0.8. Into time is 1.20631. 0.965. One second. This value is in days, na? So you have to convert in 24 into 3600. You have to convert this value into second because this value is in meter per second. And then I'm dividing by 10 to the power 3 because I want to get this value in kilometer. 83.38 kilometer. 83.38 kilometer. All of you guys are getting the same. Now, why this question I have given to you? My purpose is not to give you question for practice. My purpose was, have you understood how I have used these formulas? How I have used the data, which data, how to find it out, all these terms, have you all understood? That is what the purpose of giving this question. The whole purpose of giving this question is that only. Try another question. See, here I'm not giving you question for practice. Here I'm giving question just because I want you guys to be conceptually clear with the. I want you guys to be completely clear with the concept. Concept clarification is anyone solve this question? So what are the data which is given to you? Larger stream has a reoxidation constant. So they have given you K2, which is 0.4 day inverse. At a velocity, so they have given you the velocity which is 0.85 meter per second. At a point at which organic pollutant is discharged, it is saturated with, so they have given you saturation, which is 10 milligram per liter. At the same time, they have given you the initial oxygen deficit as 0. Below the outfall, the ultimate demand for the oxygen is found to be, so they have given you the L0 also, which is 20 milligram per liter. And the deoxygenation constant, that means they have given you the K1 also, which is 0.2 day inverse. What is the DO at 48.3 kilometer downstream? So first of all, I have to find out T. T will be length divided by velocity. So 48.3, it is in kilometers. So I will multiply this by, multiply this by 1000 divided by velocity is in meter per second, 0.85. So this value you will get in second. I want this value in days. So I will divide this value by 24 into 3600. So can you guys give me the value of time? How much time you are getting it? See, once I will get the time value, then I can use the DT formula, oxygen deficit formula. How much you guys are getting it? The time value. Zero point 6576. 0.6576 days. This much will be the time. This much will be the time. Okay. Now, for this time, I have to find out dt. The formula for dt is what? K1 into L0 divided by K2 minus K1 bracket e to the power K1 into T minus e to the power K2 into T plus d naught e to the power minus K2 into T. Now in the question, they have already mentioned that d naught is 0, so that part I will not take it. Only dt. K1 is 0.2 if I am not 0.2. L0 is 20 divided by K2 minus K1, again it will be 0.2 only, bracket e to the power 0.2 into 0.6576 minus e to the power 0.4 into 0.6576 bracket closed. Tell me the value of dt. Tell me the value of dt. I'm getting around 2.16. I'm getting around 2.161. Now this question is asking you dissolved oxygen. So after that, after dissolved oxygen at 48.3 kilometer downstream, it will be equal to DO saturation minus DT. DO saturation is 10 minus DT is 2.161. Final, how much you will get it? Finally, how much you will get it? $7.84 according to Priyanka. Approximately 7.84. Okay. Now tell me whether you have understood this concept or not. Whether you guys have understood this concept or not. So as I promised all of you that I will be taking 6 to 7 topic. So today is 7th lecture for you in this 𝐂𝐤𝐻 English channel. And all the topics which I have discussed, these are very important topic. Maybe this year you will get questions directly from this topic itself. So I try to help you in whatever time which is available for me in that best possible way. I try to help you. Still, see, this classes today is the last class in this series for environment, but definitely in future also I will help you. If you need any other doubt discussion or anything like that, you can simply ask me in this Telegram group. So I think most of you guys are already in this Telegram group. Those who are not, for any guidance related to the GATE 27 preparation as well as for any competitive exam preparation, you can discuss with me here. And even for the technical doubt, not only related to the environment, but you can ask doubt for fluid mechanics also, hydraulic machine also, open channel flow also. All this topic doubt you can ask me in this Telegram group. I will try to help you in my best possible capacity. Okay, so I hope all these 7 topics which I have taken you all have enjoyed this topic. Somebody, like many of you have seen, they are watching it as a recorded. So it's up to you. If you are available at this time, at this timing, definitely I will recommend to watch these classes as a live. But if you are not able to watch and you are watching it as a recorded, I don't have any problem with that. But try to clear all your doubt either through Telegram or maybe other option if you have. So try to clear all your doubt. That is the only thing I will say. Okay, so with that, bye-bye, take care. We'll meet again with some other session. Till then, take care. From tomorrow, I will not meet. This is the last class for the environment session. We'll meet, but for different session, not for this one. Bye-bye, take care. Jai Hind.